portion of this video is sponsored by FlexiSpot. I've always loved roller coasters. When I was a kid, I really wanted to become a roller coaster designer, and now I am, at a smaller scale anyway. Modern roller coasters feature a ton of cool technology, but for now I just want to focus on the train design and the launching aspect. More specifically, LSM or linear synchronous motor launches. Linear motors are not unique to roller coasters. In fact, a 3D printer recently launched using these, which is really crazy. But coasters do feature perhaps the most powerful applications you can experience as a normal citizen. How does this tech work? Well, it's really not that complicated. First, remember that electricity passing through a coil creates a magnetic field. If you have a permanent magnet nearby with the same pole, they will repel. Opposite poles and they attract. Now add a few more coils in a row, and by applying power to the coils in a very specific pattern, the magnet will move. Enough learning, let's blow some stuff up. These are the first coil boards I generated. I just made them an arbitrary size so I can test some things. Also, I love KiCad, but you can't make curved traces in it. So these are really just a ton of straight segments that I had to create a Python script to generate, so that was kind of fun actually. Now these samples let me do some actual coil resistance testing to see if what I calculated is correct, and more importantly, functional testing. A little bit of soldering later and I had my first hint of performance. And this was way better than I expected. But there's a catch. Fire. Okay, fine, but certainly a lot of smoke. That's because I am way overdriving these PCB traces. I'll be pushing enough power through these tiny traces to cause permanent damage after just a few seconds of continuous activation. Yeah, lots of magic smoke. Do not breathe this stuff in. Thankfully in this application, they'll only need to see the power for a very brief amount of time, but it's still enough for them to get quite warm. This is why in larger applications, they typically integrate liquid cooling into the coil assembly. But for me, air coiling between runs should be just fine. With initial tests looking promising, I made some tweaks to the coils. Then I placed an order for those and a prototype coil carrier. While I waited for them to arrive, I took on the mechanical portion of this design. I should have kept things simple here too, but I did not. I wanted to make this as functionally accurate as I could while keeping it desktop scale, and this is what I came up with. Each wheel assembly has 6 bearings on it, and 4 of those are independently compliant using an O-ring as a spring and a paper clip as a pivot. I'm really glossing over this design. It took a lot of brain wrinkles to make it reliable, repeatable, and easy to assemble at this tiny scale. Thankfully, 3D printing technology has come a very long way. Each wheel assembly is connected by a crossbar, and that crossbar is then attached to the train base. This base allows for any shell to be simply bolted on top, and you bet I'll be doing that later. This first train I have is just a test platform, so it has no couplings and it's over-constrained, but it'll work fine on a straight track. Now with the magnets very securely taped in place, I can focus on the track, which will use brass tubing. Yeah, it sounds pretty good. This tubing is advertised as highly formable. We're gonna test that. It's assembled to the crossbars using a lot of superglue. Okay, we have a car, a track, now let's get it moving. This breakout board I made will let me test all the features of the launch coils without committing to a final form factor just yet. This meant I had to solder a lot of connections, and after initially messing up the polarity of half the coils, I got it working. Now in addition to coil control, I also prototyped the AND gate blocks, which I'll use to enable and disable sections of coils, as well as this IR proximity sensor to keep track of the train position in real time. I then proceeded to test neither of these because, well, I don't make mistakes, so why bother, right? If you're wondering why I need the ability to enable and disable coil segments, well, remember how I said I'm overdriving these coils? This means I want to avoid powering coils that are too far ahead or behind the train, and thus not helping accelerate it forwards. This launch section has nearly 100 coils, so if I tried powering all of them in sync, I'd run into serious power limitations and risk overheating. Alternatively, controlling each coil individually would require a huge number of electronic components and a lot of microcontroller pins to control them all. As a middle ground, I split the coils into 6 zones. Each zone will turn on as it's needed and turn off once the train passes. To power these, I will need 6 signal lines. 3 will control which coil receives the high voltage, and 3 which receives the ground. This is where the AND gates come in. Rather than generate these 6 control lines individually for each zone, instead I'll generate one master set of 6 signals. Then using the AND gates I can control whether or not these signals are allowed to pass through to each coil segment. Cool. While waiting for the final boards to arrive, I played around a bit with tuning and different loads on this single test segment. Unfortunately, the train has a lot of rolling resistance. Adding weight makes it behave a little better, but much more slowly. Perhaps degreasing the bearings will do the trick. Works for fidget spinners after all, but no, that really did not help with these garbage Amazon bearings. In fact, a whole bunch seized up after I removed the grease. So I'm gonna add a little bit of thin oil back to the survivors and just carry on. But I have another idea I can try later if needed. and look what just got here. Thank you to PCBWay for sponsoring this portion of the video and providing not just the bare PCBs, but also for my first time ever using their assembly service. I really should have done this years ago. It was so much easier. Now to attach the coils. I wanted to keep a very clean form factor here, so I tried something new, edge soldering, which really just involves putting holes at the edge of the board and crossing your fingers. And my implementation was an absolute nightmare to solder, but it kinda works, so it's fine. Now while the coils look cool, the coil carrier is really putting in all the work here. It not only has the brushless motor controller on board, but it also handles all of the connections between each individual coil. PCB routing here is, well, not my proudest moment, but the end result looks really good. The big question though, does it work? After verifying basic functionality, I threw on a Teensy 4.1 and loaded up some code. Dang, not quite yet. That actually turned out to be a cold solder joint on one of my edge connectors. Take two. No way, it's actually working. I mean, yeah, of course, it's working. Most of the time anyway. Occasionally, the train will vibrate in place, and this is because I'm doing something called being lazy. Remember that the synchronous part of LSM means that the coil control needs to be very precise to move the magnets forward, and without any feedback on the magnet position, I have to resort to using physics and calculations. But because of pesky things like resistance, friction, thermals, often the ideal acceleration profile is not actually ideal. To fix this, I will need to get real-time feedback of the magnet position, i.e. those proximity sensors that I didn't test before. I guess I should test them now. And would you look at that, they aren't working so great. No need to point fingers, but some genius wired the component completely wrong, and now it's wrong on every segment, and reworking would be a huge pain, and reordering would be a huge pain, so I bought a LiDAR sensor. There is certainly a lesson to be learned here. For somebody else. This LiDAR claims to be accurate within 1 centimeter and can run at 250 Hertz. So it can probably run real time, but if not, it can at least help with tuning. It was very easy to get it up and running, so I'll keep this in my pocket for later. Before that, I want to build up another coil segment and test zone enabling and disabling. Sure enough, that's working perfectly. Did a few more tests before realizing that 30 volts is not enough. These coils are quite a bit higher resistance than I had expected, so I can just up the voltage to 60 and see what happens. 3 green lights means we are good to go. Much better, and these coils are now getting a little warm. Nothing concerning though. I actually went a little crazy with this PCB design, and it can handle up to 100 volts, but that is a lot, so I'm gonna stick with 60 for the time being. Next up, more train cars, and over-constraining the lead car. I strayed a little away from the authenticity here and went with a ball coupling design. Ideally, this bit would also rotate and be spring-loaded to the center, but I didn't do that. So yeah, now we're cooking. All these extra bearings though, a lot more friction. I bought some lead shot with the thought of adding mass to the trains. I'm not sure if it'll be enough, but I might add that back in later. What if? Oh, yeah, that's much better. So these O-ring springs on the lower wheel assembly are just clamping way too tightly. I bought some squishier rings that should lower that clamping force, but for now I'll just roll without them until they arrive. I then built up the rest of the launch segments. After validating that each one is working nominally, the moment of truth is now upon us. Full-length train, full-length launch, send it. Not bad at all. I know more speed can be teased out though. Before I get to that, some housekeeping. And also, I kind of broke one of these, but it's fine. I'm just gonna use 5. Now I definitely need a ramp so I don't just send the train off the table. So I built this little tube bending jig and played around with it until I have something that looks right. Turns out, yeah, these tubes are pretty easily formable. Next up, I added some drive wheels. These are good for positioning trains at lower speed before they actually launch, like to align it with the launch segment. Unfortunately, I forgot that motor drivers are kind of needed for this, and I don't have any on my control board, so I soldered on this little doodad. And that, kids, is why you should always break out some extra pins on your custom control boards. The new O-rings arrived too. They're way squishier, which should be way better. Here is the friction with the old ones, and here it is with the new ones. And finally, some totally unnecessary, but absolutely necessary lighting. Put it all together, and
time on my ride. Taking my time on my ride.
Nice. But what about the LiDAR? Honestly, I don't know how much it's going to help here. The train is accelerating really quickly, it just needs more weight and less friction. But I'll still give it a try and see what it can do. Yeah, it makes some pretty plots, and I could totally use this to optimize my launch profile in the future to get some more power, but feature creep is my downfall, so I'm gonna save that for another time. Now I'm also missing brakes, but clearly those are not required just yet. Before needing brakes, I have to totally rework these wheel assemblies so that I can actually go up an incline without jamming. So if you want to see a future update on this project, maybe with a full demo roller coaster track, let me know down below. That is a long shot though. And while you're typing up your unnecessarily nice and genuine comment, let me tell you more about FlexiSpot. I was already in the market for a new desk when FlexiSpot reached out, and I'm honestly really glad they did. They sent me their E7 Plus standing desk with a huge 72-inch bamboo desktop. If you've never used a standing desk before, you gotta give it a try. It's good for stretching your legs while getting your work done, like I'm actually doing right now, but even better when you're working on projects and want to get a good view without having to hunch over everything. Plus, this desk has a weight capacity of 540 pounds, so you can put just about anything you want on the desk, including yourself. You do you. I took this opportunity to set up a new mini workspace. A nice benefit of having such a solid desk means my 3D printer vibrates so much less and runs a lot quieter, especially compared to when it was on my old IKEA special desk. I even bought and applied some LED strips to the back of the desk to give it a nice backlight effect. And the fact that I could raise this desk way up high to attach the control boxes underneath made it way easier to install. The E7 Plus desk has a 15-year warranty and 30-day risk-free return, so you can be confident in your purchase. They have all kinds of different desktop configurations to fit your space constraints. And they also sell a few other models, which include some T-frame styles at various price points, down to as little as $150. Or if standing up isn't quite your speed, they also sell a range of ergonomic desk chairs. And if you act now, you can take advantage of FlexiSpot's fall sale with up to 50% off. Use my exclusive code to get an extra $50 off on an E7 Plus, E7 Pro, or E7L. Check out my link in the description to upgrade your setup and help support my channel. Thank you again to FlexiSpot for sponsoring this portion of the video. And a special thank you to all my Patreon supporters for your continued support. Let me know if you want to see more roller coaster content in the future. I know it's not Nerf, but maybe this will be my next year-long project. Anyway, bye.